I'll go through, I'm good to go. All right, good afternoon, everybody. My name is Matt. I work at Vectra Networks. You probably haven't heard of us. We're a young Silicon Valley startup who specialize in the application of artificial intelligence and network security. And what I want to talk about in the next 18 minutes is how we can use artificial intelligence to fundamentally change how quickly we can spot in-progress attacks inside your network. So, let's just turn this on. There we go. AI is the next industrial revolution. It will touch most parts of your life, at work, at home. I think we're all seeing that with autonomous vehicles. So it's probably unsurprising that at a technology event like this, you're hearing a lot about AI or machine learning. Machine learning is really the science of programming in artificial intelligence. And it's going to fundamentally change how we approach security, to automate decision-making, to automate detections. And we're already seeing large investments from organizations across the board, trying to create new value and new capabilities. But if we think about how we handle security operations, I would argue that we're stuck in the past. We may have very latest technologies, but the people and the processes of how we use those are still very manual in nature. Think about a security operations center. You probably have a security analyst handling alerts, manually trying to filter out the false positives, the noise, trying to figure out which is really salient information. So the SOCs need to change, and they need to change for a number of reasons. First of all, we as security professionals are fighting an asymmetric war. It's not fair. It's never going to be fair. The opposition have got more resources than we have. So we have to fight smarter. You know? The threats are increasing. The attack surface is increasing. IoT, mobile devices, insider threats, ransomware. And the resources that we have to fight and respond to those are finite. The human resources that we've got and the skills and competencies that we have are finite too. And in fact, our competencies are based upon our experience of fighting yesterday's battles, not tomorrow's war. And the people that we need to fight that war, the security analysts, the researchers, the threat hunters, they are a precious resource. They're very hard to recruit, and they're even harder to retain. There's a massive skills gap in our industry for cybersecurity specialists. So we've got more threats and a real resource challenge of how to address that. And I'm going to show you a way of addressing some of those pain points by introducing artificial intelligence into your security architecture. Not to replace human beings, but to augment them, to force multiply their capabilities and drive security value back into your organization. Because today, it takes on average, according to FireEye, our previous speaker, 146 days on average before a threat that is active inside the network becomes apparent. In fact, in 50% of those cases, it only becomes apparent because an external party has notified us about it. So 156 days, these threats are inside the network. And I think we can all understand that no defense is perfect. Defense is a rational response, but an imperfect response. So the question is not if I will have a breach or a threat inside my network. The question is, when will I have it? Where will it happen? And to what degree will it impact me? So the ability to blend defense, detection, and response together helps you build an adaptive security architecture that drives down this 146-day gap. Oh, and by the way, 146 days in the network, but only 3 days required before I get admin privileges. So 143 days where I've got the keys to the kingdom. Imagine the damage that can happen during that time frame. We have to change. We need to shrink this detection gap down to minutes. And if we do that, we give ourselves the possibility to intervene far earlier in the life cycle of a building attack inside your network. And intervening early can make the difference between a troublesome security issue and a full-scale breach. Just like healthcare, you want to catch it early, intervene early, so we can positive. So we need to shrink this cybersecurity gap. So how can we shrink it? Well, the first thing is we can throw more resource at the problem. All right? We could hire more people. Let's get more analysts. There's more alerts, there's more going on. There's lots of technology out there that can tell me interesting things. Let's just throw more people at it. Let's do more, but at scale. But we've already seen that security headcount is very, very hard to retain and hire. So that's a challenging proposition. They've been trying to fix it just with more manpower. So the second option is to automate some elements of our threat detection, augmenting our staff with artificial intelligence. Automation is actually, I think, the only rational response to a world where you have a tsunami of data and alerts coming in. How can we triage those before the human being touches them? Of course, there's always a third option, which is to do nothing. But that's really not an option if you're accountable for protecting the brand and managing the risks inside your organization. So you have a choice to make. Do you carry on working the way you've always worked, just trying to do it with more and more people, or do you take a more progressive approach to augment them with artificial intelligence? But AI isn't just about looking for weird stuff on your network. It's not just about anomaly detection. Just because it's weird doesn't make it bad. All right? So an approach for artificial intelligence that can create value, it's about not looking for weird stuff, it's looking for the individual behaviors that attackers demonstrate. So focusing on an AI instance, looking for discrete attacker behavior. Behaviors, not instances. I don't care what it is. I don't care what the exploit is. I don't care what version or variant of the malware is. I just care what it behaves like. And if you take a behavioral approach, that means you're also covered for zero-day risks as well. Because even if I don't know what the threat is, I will spot it by the way it behaves. Because the behaviors that threats demonstrate inside are bounded. So just going for an anomaly-based approach really doesn't work. Just trying to baseline what my network looks like and then saying anything that falls out of there is bad, I'll alert you, is very noisy, gives you false positives. What we need to do is focus on the attacker behavior. Yeah? And if we do that, we're able to look inside the life cycle of the attack. Because the things that these attackers seek to do once they've gained a footprint inside your network don't really change. They'll look to orchestrate and control, so command and control, C2. They'll look to reconnaissance the network, to understand the IP landscape and the hosts and the assets around there. They'll look to move around the network, and as they move, they'll look to escalate their privileges and their capabilities. And once they've done that to a certain level, they'll then get up to the mischief that they want to, be that botnet, ransomware, or more worrying, a targeted attack looking at to exfiltrate your data or manipulate your data or perhaps even just hold you to ransom over it. So each step in this kill chain, there are multiple opportunities to spot the behavior, but those behaviors are very quiet. They're a very weak signal in the deluge of traffic and communications that are happening inside the organization. And so let's look at here. What we're doing with artificial intelligence is using machine learning in multiple ways. So let's just talk about machine learning for a minute. Let's break it up into some compartments so we can understand some of the differences to help you evaluate it. First of all, let's look at what I call a supervised learning model. Supervised means it's been pre-trained in the lab before you expose it inside your network. Past labeled data, known good, known bad. And even within supervised machine learning, there are multiple techniques and mathematical algorithms that we can use to do this. So supervised learning is very good when you can have a stable set of data to manage. Very good for spotting command and control. Very good for spotting data exfiltration. So we will use that. We will pre-train these algorithms before we release them into a production environment. So they've got an IQ straight away. They continue to learn, but they've already been trained and go to work. So there's no waiting period. They're very good at malware and things like that. But there will be things about your organization that are unique, that nobody could ever know in advance. And so we need to blend supervised with unsupervised learning models. An unsupervised learning model has 0 IQ when you turn it on. And it learns over time by observing what's happening in your network. Use cases for here might be trying to understand the IP addressing schemes, looking for your subnets, your darknets, watching your administration behaviors, what protocols they're using, what hosts, where they're coming from. So by blending supervised and unsupervised and the various mathematical techniques underneath, we can tune and pick the best algorithms for the best job. We don't have a religious view that one type of machine learning is best. So we've got an algorithm now, supervised or unsupervised. We need to give it some data to work on. And if you want to spot active threats across the enterprise, you have a number of choices of where can I look? The first option would be to look at the endpoint. And the endpoint is an excellent place to get very high quality data about the executable, how it was injected, and things like that. But it requires you to deploy a piece of client software. That's not a bad thing, it's just the way it is. But if you want to consider visibility into IoT devices, mobile devices that you don't have a management control over, client-based endpoint solutions aren't going to help. I believe they are in a very important part of a security architecture, but in themselves they are an incomplete solution. You could look at some kind of sampled statistical analysis of your network using technologies like NetFlow. But here the resolution, the detail, isn't high enough to spot these very weak, small signals of those active insider threats. We could use Syslog. We use Syslog a lot in security to feed seams, to tell us about events. But Syslog, whilst a very useful way of recording events, is in the past. It's forensic. You only generate a Syslog event when you've seen the event. If you don't see it, you don't alert on it. And to advanced hackers, Syslog is in itself an attack surface. Syslogs can be deleted, so you leave no fingerprints, or they can be manipulated. So ultimately, if you want to get a pervasive view across the enterprise, you're left with using the raw network traffic, the packets, because the packets are primary data. They never lie. They've not been touched or manipulated. They're not interpreted. And so the approach that we've used at Vectra is the hardest approach, which is to take the tsunami of packets that are happening in the enterprise network and analyze them in real time to surface, prioritize the in-progress attacks and deliver those to the agent. And because we're taking a behavioral approach, we do not concern ourselves with what's in the packet. Yes, we look at the headers. Yes, we look at the timing, the cadence, the frequency, the volume, the pauses in the communication, but we don't inspect the payload. Because to understand its behavior, you don't need to know what it is. You just want to know how it behaves. And this has a benefit and a cost. The cost is, I can't tell you what's in the payload. So if somebody is exfiltrating data, my AI will not tell you which file they've stolen. But I'll tell you it's been stolen, and I'll tell you in real time. But the benefit of a behavioral approach that doesn't do deep packet inspection means that even if the payload is encrypted, and encrypted traffic is growing rapidly on the internet and certainly within enterprise applications, we can still spot the behavior. So even if these attacks are happening over encrypted channels, these hidden threats will be surfaced. Last year at Gartner Security Risk and Management Conference, they predicted over 50% of advanced attacks will be orchestrated over encrypted channels. And if you think, well, encryption, that's okay, I'll just decrypt it in the middle, that's not going to scale for you from a performance or a cost perspective. And the more advanced software architects now are even pinning the certificates into the app, so you can't do man in the middle. So encryption is going to blind a lot of traditional DPI technologies over the next few years. A behavioral approach helps you see the attackers, even if they're hidden in encrypted channels. Yeah? So encryption in flight, certificate pinning, and more internal applications are all considerations you have to have. If you're doing DPI today, it's not going to work for you in the long term across the whole of your enterprise. So the challenge that a vendor like Vectra has is how do we find the signal to noise? How do we tease out these small signals from it? And there's really two methodologies that we apply to do it. First, we reduce the noise, right? By focusing purely on attacker behavior, not just anomalies. This helps surface the attacks much easily. But then there's still a lot of information, there's still a lot of stuff that gets surfaced. So we then need to increase the volume, amplify the signal, these weak signals of attack. And we do that by bringing a level of automation to this. So what we're building in AI is an automated AI threat hunting platform that's constantly working, never goes on Facebook, takes a coffee break, or goes to the bathroom. 24/7 is monitoring the network and then showing you the highest priority risks, giving you the context of what's happening, and explaining what you want to do next. So where do we want to examine? Well, of course you want to see the internet ingress and egress traffic, because that's where a lot of external bad actors are. But you just as much want to see the campus network traffic, because the campus is where your users are, and your users are probably your biggest threat, because they're bringing in, walking in threats unbeknownst to them. So we want to see the campus network. So we probably want to inspect the traffic from the core switch in the campus. But if you think about the digital assets that you're charged to protect, they're living in the data center. So it's just as important to instrumentate the data center. And with over 50% of traffic, 80% of traffic even, staying within the data center, you can't just rely on your perimeter defenses to spot threats that are in the DC. And the data center infrastructure is a very weak attack surface as well. Whilst as an industry we've done a very good job of top-down securing applications, policies, segmentation, if you look at the fundamental infrastructure of the data center, the racks, the servers, the shared drives, the arrays, they're easy to attack with sub-OS rootkits, with IPMI, so management protocols that have not been secured. There's a big attack surface there as well. So the ability to spot an attacker means you need to have visibility across the whole enterprise, and that's why the network really pays off. It gives you the chance to see the network. And so what we end up with is a world where we've got thousands and thousands of alerts and noises, but using AI to filter them, to act as a virtual first-line security analyst, it will turn that noise of the alerts into specific detections which have context and understanding. We'll feed that and correlate them back to a particular host. So we're constantly, in our AI minds, watching your network traffic to understand where the hosts are. Are they moving around, if they're mobile or endpoint devices or VMs, and tracking and correlating them too. And then once you know which host has got the problem, you can drill down into the host, get the context, even get the packets associated with the detection to go back to that primary evidence. So you've automated the detection phase of that first line analyst. And we're taking it from days and hours down to minutes. So instead of just trying to fish through the sea of alerts, we know exactly what's going down, where, and why we think that. And then the next stage is, how do we remediate? What is the appropriate action to be taken? And the technology is already there to automate some or all of the intervention you want to take. So Vectra's AI is able to talk to your SIEM platform, generate Syslog events, even have micro apps that's running inside them that give you context. So instead of having 600 alerts failed login, have one alert that says brute force attack. Here's why. Here's the user. Here's the context. Here's what the machine was doing before. How about talking to your enforcement? We just spotted a brand new, never seen before CNC, command and control server, somewhere out on the internet. Let's pass that information out to your defensive suite. Let's block it on your firewall. Now, you may not want to automate that completely. You probably still want to have a human analyst make the decision to block, but you can streamline that operation so it happens almost instantaneously. And so your ability to react is turbocharged, many, many, many times over. So we're at the point now where we can automate threat hunting inside the network. We can integrate into the security operations centers that you operate and integrate with the enforcement points that you have to block or to isolate your devices. Here's an example. This is the third largest healthcare provider in the US. They had a ransomware breakout last year. And I want to show you the steps that Vectra identified and the help that we gave them. The first thing we spotted, well, we spotted a couple of things. We spotted a command and control into a suspect domain. We spotted some reconnaissance, and we spotted ransomware happening. And what we did is give that customer a short but meaningful window to respond before the ransomware hit and began to propagate. Right? So first thing we spotted was the command and control activity. Brand new domain, not on any kind of reputation list. You would never know it was coming from there. We spotted it by its behavior. All right? So we spotted a suspect domain behaving like a command and control channel. All right? A few minutes later, we then saw the same host start to perform port scans using the SMB port. Right? It was looking for shared drives of target for the ransomware. And after about 45 minutes, it began doing the read writes across the SMB share. So we had a 45-minute window where the customer was able to identify the infected host, run to it, and pull it off the network quickly. Now, in this case, they weren't quick enough. It did begin a little bit of file encryption. But imagine the ability to spot ransomware when it pokes up, to quickly automate the isolation of that host, get it re-imaged, and it stopped you having the problem of these threats popping up all around the network. So we went from a problem that would take many, many days to resolve down to doing it in minutes. Now, here's some examples. Tribune Media are a very big publishing company in the US. We reduced their incident response process down to minutes. Right? One of the largest European farmers are currently running Vectra. They're doing the same. Their incident response is down to 15 minutes. That's remarkable. It's a step change from where we are. And we must realize that the intensity and the velocity of threats that we're going to have to handle as security professionals is only going to increase. And your resources are not going to increase at that pace. So automation is going to be fundamental to your security success. So, improve your alert management. AI is a way of really, really reducing the number of alerts your teams have to manage and prioritize them so you can pick the salient results. It will give massive efficiency gains to your investigation process. Automate where you can, reduce the time needed to investigate those alerts, and manage the number of precious staff that you have to be able to do that. And ultimately, find those bad actors quicker, earlier in their life cycle, whether they're opportunistic, whether they're advanced targeted, or whether they're insider threats. They will all manifest themselves inside your network, and the AI is able to spot them. And because we're network-based, we're pervasive across the network. And finally, this is a passive technology. Passive, that means it doesn't interfere, it doesn't add latency, it doesn't add a failure point on your network. Because ultimately, whilst we're tasked with protecting our organizations, we must do no harm to the day-to-day digital activities that they do. So AI really gives you that chance to partner, to blend advanced technologies, learning, cognizant technologies almost, with your human resources. If you'd like to see Vectra in action, I'm over at the booth for the rest of the day. We have a technology evaluation program where you can experience Vectra's AI running inside your network. If that's something of interest, please come and grab me afterwards. But for now, thank you very much for your attention.